So this next section, section 4.2, both A and B, is really some foundation work that you're going to need in order to do something important with your integration. So we're going to basically extend just a little back to your ground knowledge that you had about sequences and series. Okay, so hopefully you remember this notation, sigma notation, and of course this value down here tells me where to start, and the n value tells me where to stop. And we could think of this as the lower bound, and n, whatever's up top, is the upper bound. And of course it means I'm adding up all the terms from the first one until I get to the last one, whatever that might happen to be. And you've seen this before, like I said, when you did sequences and series. And so we are just adding up n terms. We just don't know how many n happens to be. And the sum of n terms, so this little notation down here at the bottom, or the little subscript, is the index of summation, and we either use I, or we can use j, or sometimes they use k. So just so you'll be expecting that it might not always be I. And then of course this one is the ith term. I don't know which term that is until you tell me how much the last number is up here. So that just means any term. And then, of course, the upper bound we said was n. The lower bound is 1 if we're starting at 1. And note that we don't have to start at 1. We could start at 7 if we wanted and go to the 12th term. But typically, we start at 1. That's just if we're trying to be tricky. You know I would never trick you, right? But, of course, it does have to be a whole number. Can't be negative. Can't be a fraction or a decimal. Okay, so some properties about summing are these rules that I've written over here on the left, and I'm going to give you some examples. So let's say, I'm going to work off of this side first, that my series that I was adding, we'll put the 2 out in front, was, actually let's do this. I'm going to give you an example. So let's say that this part right here, oops, I didn't mean to do that. So let's say that this series that I was adding was the even integers. And let's say that they turned out to be 2 plus 4 plus 6 plus 8. So all of that turns into this pattern. Because remember, a series is nothing more than a pattern. And so if I have a coefficient out in front, as a matter of fact, let's not even call it 2. Let's call it 3. So if I have that out in front, of course, I could distribute, and it would look like this. Which would be exactly the same if I had had it on the inside to start with. In other words, I would have been adding up all of the terms, but every single one of them would have been multiplied by this constant in front, whatever that coefficient constant is. So it doesn't matter if I pull it to the front, which this could be kind of an advantage in working out everything inside the brackets first and then multiplying by 3 instead of doing all of the multiplications by 3 first. Okay, so then the second one says, if I'm summing up two patterns, that I could split them and add them separately. So, for example, here, if I had, let's say, the first term was 2 plus 3, and then the second term was 3 plus 4, and the third term was 4 plus 5, and the next term was 5 plus 6, and so on. And what I notice is it's n and n plus 1, that I could have in fact said, hey, you know what? There's two separate patterns going on here. I notice that the first pattern is the first set of numbers, and that would have been this part. And then the second piece, or the second number in the set, again, it's its own pattern, and that's the B part. So I could pull them apart and do them separately, and of course it would look like this, where I would have 2 plus 3 plus 4 plus 5 plus up to n, and then I would be adding the second piece, which would be the 3 plus 4 plus 5 plus 6 plus n plus 1. And of course, that doesn't make any difference which order I add it in. So it's all about convenience for me. Okay, so some summation formulas that are going to be helpful are these. You will have to memorize these. And here's an example of the first one. So let's say I have the summation of just a constant. So the shortcut is it's the constant times whatever the stop number is. So for example, we're going to actually expand this out. This says sum up a bunch of 2's. Notice there's no I in the expression with the 2, so there's no place for me to substitute in a number. So every time I'm summing up a 2. And so I need to do this. This would be the first term, and then this would be the second term, and this would be the third term. And I go, how many terms am I supposed to do? And you say, Torres, look at the top. You're supposed to do 5 of these. I go, oh, okay, so far I have 1, 2, 3, 4. Ooh, I need another one. And of course the shortcut is that constant times the stop number, which is 10. So that's a relatively simple one. Okay, so on this next one, again, here's the formula, is take whatever n is, and then multiply by the next larger number and divide by 2. So let's say, for example, that I was looking at this summation of I from 1 to 15. Really, all I'm doing is I'm adding up the terms 1 through 15. And you might remember this formula from Algebra 2. That formula actually looked like this. You memorized it like this. Times a1 plus an, something like that. And so when I look at this, I go, oh, the shortcut is, let's see, I take the last term, which is 15, and I multiply by 1 more, which is 16, and then divide by 2. Now, you know how I hate memorizing, so let's talk about why that is. If I looked at this set of numbers and imagine it was from, let's say, 1 to 100, and I wanted to minimize my task of adding up the numbers, well, I could start to do some pairing. And I notice something special about every pair. Oh, yeah. They always add up to 16. And so that's where I got this a1 plus an, was add the first and last term. And then I want to take, so I go, well, I wonder how many sets of those there would be. So if it was, let's say, 1 to 99, there would be 49 and a half of them. If I did 1 to 100, would you agree that if I paired them up, I had 100 numbers, so it would give me 50 pairs? And if I did, let's say, 1 to 50, I would have 50 numbers, and if I divide by 2, it would give me 25 pairs. And so it's taking that last number and it's telling me how many pairs. So because 1 to 100 is 100 numbers, and 1 to 50 is 50 numbers, and so 1 through 15 is 15 numbers, and divide by 2 because that's how many pairs I have. And of course then I can just work it out. And that kind of helps cut down on you having to memorize necessarily the formulas. And so this would really be, what, 15 times 8 if I decide that I'm going to reduce this way. And so I get 120.